Anyway, 2003, he issues what he describes as a grand challenge for computer science. In the UK, the Science and Research Council was trying to gather, these grand challenges, right? It was interested in promoting science and finding really hard problems that need to be solved. And he issued this challenge, which is a grand challenge, and he called it the Verifying Compiler Grand Challenge. And there's a whole bunch of papers that have been written, and you can go and read them if you're interested, by him, but by lots of other people about this. And a verifying compiler, what is that? Well, this is what he said. A verifying compiler uses automated mathematical and logical reasoning methods to check the correctness of the programs that it compiles. Mathematical and logical reasoning. So we're going to see what that means in a moment. So I'm just going to start with absolute function. Okay, so let's go like this. So what does the absolute function do? Yeah. Turns negative numbers into positive numbers. Okay, so let's just write a couple of bits, shall we? If x is greater than or equal to 0, return x, else return 0. Okay? I know it's probably not quite what you meant, but let's go with that for now. It's actually a fair interpretation of what you said, in fact. if x is a negative number, then it's just going to return a positive number, right? Yeah. Okay, so the first thing we notice, can you see that? Is it big enough at the back? Yeah? Some thumb? Okay. Whiley uses indentation syntax. It doesn't use curly braces like Java, okay? The reason for that is it forces you to indent your code in a nice way, and I think that's really cool. I take it from Python, and I quite like Python. It can be annoying, though, and it's one thing you do have to look out for, is if you are, in fact, it won't even show up here. Let's do it like this. I'll just do something random. Oh, yeah, x equals x plus 1, right? Ooh, where's my mouse? It's down here. Just turn that off. Okay, so at this point, I wonder what the error message is. Unexpected end of block, right? And so what you can see is that I've just got my indentation slightly off here. It doesn't like that, okay? And the error message, unexpected end of block, not necessarily the most helpful error message of all time. But if we push this like this, then it should be fine at that point, all right? It's just one thing to watch out for in terms of the syntax. Who's used indentation syntax before? Hands up. Okay, wow. So a lot of people. So it's not really too much new stuff then. I won't go on to it. I love indentation syntax. I think it's the greatest thing ever. Yay, indentation syntax. If you don't like indentation syntax, don't tell me. That would be bad, okay? Just keep it to yourself. That's my suggestion. Okay, right. So what are we going to do? So what I want to do now, I want to start to add a specification for this absolute function, all right? And I'm going to start with what you said, all right? So let's go like this, and I'm going to write an ensures that we saw in the last lecture. Okay, so I'll just write a little comment for that. Must return natural numbers. Yay. Sweet. Okay, so this looks like it's a specification. And it looks like my program actually implements that specification, meets that specification. So what we're going to do, I'm going to turn on verification by clicking on that. And then I'm going to run compile. And at this point, it is then going to check that the function meets its specification. And in this case, actually, it did, and it worked quite well. Very quickly, indeed. Sometimes it takes quite a lot longer. But let's just check that it's actually doing that. So if I put in -1, then here my post condition is not going to be met, right? So it should tell me. So let's see what it does. Oh, and so it does. And what does it say? Shocking. Post condition not satisfied. All right? And that's, in essence, that's it, right? I mean, okay, there's a bit more to it, but ultimately that's all it is. It's just a compiler, just like the compiler you've been using, Eclipse, for example, and it's just like type checking, but it just does more stuff. It's not as nice as Eclipse. You've got to press compile every time you want it to actually check the code. Okay. One of these days I'll write an actual, incremental editor for it, but that's a little bit off. All right, so we can put this back, and we can go like this, and that's the problem. That's going to be fine. Let's try a few other things. Let's go like, if we return x, then that would probably be a problem. Yeah, that's a problem, because obviously x is negative at that point. We could try returning minus x, and that should be fine, because of course if x is negative, then minus minus gives us positive. Sweet as. Okay, so I'm going to go back. Ooh. Ah! What did you do, you piece of junk? Oh, doesn't like that. Oh no, thank God. Sorry, it's just because it's, and then doesn't matter. All right, it's trying to do this in a web browser. All right, cool. So we've got this. This is what I want to go back to. So now I want to think about this, and I want to ask the question, this is not quite what I imagined my absolute function doing, is it? So what do I need to change to my specification to make it do the right thing? Right. So the key at the moment is that it just can return any positive number. It doesn't have to return x or anything. So we could do this, right? And that's going to be fine. So we need to say it's got to return x, or if x is negative, then it's going to return minus x, right? So what we're going to do, return x or negative x, ensures r equals x, or r equals minus x, right? Like this. And let's just put that back. And now it's telling me I've got a problem. My post condition here is not satisfied. This one is okay, though. Didn't mind that one. So what am I going to do? Going to fix my code, right? How am I going to do that? Return minus x. Yeah, all right, good. All right. So we go like this, and voila, we're done. Sweet. Okay, so that's pretty easy. Not rocket science. Not rocket science. All right. Good. Okay, so we're going to do another example. So we're going to do a couple more examples. Let's start with the max example. Int y. So let's get rid of this. And let's, what the hell, that'll do. We'll leave that as my implementation. Okay, so this is a max. The max function is supposed to return the largest of the two parameters. So what's the specification? What should I put as a specification? Just let people think about it for a moment. Okay, lots of hands going up. Spoiling everyone's fun. Okay, okay, let's put that down. Ensures r is greater than or equal to x and r is greater than or equal to y. Okay, good. So let's start with this. So we'll start with that. Okay, so that's telling me my implementation is just absolute junk. Let's try, what am I going to do? Oh, I know what I'm going to do. I'm just trying to think how I'm going to break this. Let's try that. I don't know if that'll work, actually. No, it won't work, will it? No. Because if y is negative, I'm going to go down, aren't I? Okay. So, okay, I want someone to tell me an implementation of this that works that isn't the actual implementation. Yes? Okay, that's not going to work, though, is it? All right, because it's not greater than 1. Go on. X plus... There is no... There is no infinity. So, all right, I think how we do this is we do something like this. If x... we could do if x is greater than or equal to y. Let's do this. What the hell? X times y. Do you think that'll work? I don't know if my compiler will handle that, actually. Because if one of them is negative, it won't work. No. Good thinking, but no. I'd have to write it out again, though. Let's try this. Y plus 1. Okay, how about this, right? I think this is going to do it in this case. Yeah, okay. So that's a valid implementation of your specification. It's not quite what I wanted, though. What else do I need to put in? Okay, yeah.
That r is equal to x or is equal to y.
Right. So let's go ensures r equals x or r equals y. Bingo. Okay. So now it's telling me that's not right, so let's just fix that. And then it's going to tell me, oh, that's not right, so let's fix that. Yes.
It generates the function.
Okay, so the question is, if we wrote the specification for a function, would it be possible to write a tool that generated the body of the function? That is an interesting question. I'm going to say that is an open research question. In some cases, I think it's definitely true. In the case of Max, I think it probably is actually doable, because the specification pretty much dictates everything, right? I mean, the specification tells you everything that has to happen. In some of the functions that we're going to see, there's a lot more possible variation between the implementation and the specification, in the sense of we've got a specification, but there's quite a lot of different ways we could implement it. And some of those different ways would have different algorithmic complexity even, for example. So at that point, I feel like it's too difficult. But it's like a...
Looking at it that way, as long as the result matches the specification, would it matter how it's implemented?
That's a fair question. I don't know the answer to that question. That's research, I guess. But look, you're not the first person to ask me that question. And I do know that some people are interested in that, yeah. So it's a good question.
What happens if our ensures postconditions contain a contradiction?
What happens if the postconditions contain a contradiction? Okay, so what is the minimal contradiction, I guess? Right? I think the answer is basically it will not verify. Ooh, what's it doing? I think we could say that's not great. That's what you call an internal error. It's basically saying, okay, that's slightly better. Ensures x does not equal x. Yeah, that's going to work. And it's going to say now, postcondition not satisfied. It's not going to matter what I put here. It's never going to be able to prove it. The ensures false case, I don't think that's a bug. Okay, you should file an issue for that. Yes? Right, okay. Okay, so I think that's what you're saying, is that right? No. Basically what actually happens is, effectively, it just conjuncts them together. So it'll take them and it'll look at them like that. So so it's combining them together. In this case, it doesn't actually prove a contradiction necessarily, but and so it's actually a fair question, and I should actually mention this whilst we're here, since we've got a bit of time, and I want to do a few more. But splitting them up into different clauses, I think, helps the readability of the pre- and post-conditions. And it actually also helps the verifier. So if you have a really long precondition or a really long postcondition, and you're finding the verifier is taking ages to verify, then breaking it up into multiple ensures clauses can actually make it go faster and give you more chance of success. So it's worth doing it for that reason. Yeah. So actually, it does ring the bell that we actually haven't seen a precondition yet, of course. So let's just put in a precondition for the sake of argument. X is greater than or equal to 0, and Y is greater than or equal to 0. How's that? Okay. That'll do. It's just I haven't got a postcondition, but it doesn't matter. Okay, so that's my precondition. I've got my it requires, and let's write another function here. I don't know, let's call it f. Doesn't matter, int x, just for the sake of argument. Int r. Okay, and this is going to return f brackets. No, it's going to return max brackets x comma x. So what do we think about that? Going to work or not going to work? Thoughts? Yes.
Do you need to require for the function f as well? Because
So basically what's going on here is that f can take any possible x, and it's passing it into this function, and this function wants it to be greater than or equal to 0. And those two things, they're not meeting, right? So we should find there's an error. And indeed there is. And what does it say? Precondition not satisfied. That's right. And so you suggested, well, what if we added a precondition here? And we remember this, right? If you remember non-null, when we do the non-null analysis, you put a non-null on a parameter here, and then you're like, oh, stuff, now I've got to put one up there, and down here. Well, it's the same deal, right? So if we did this, then, yeah, that's okay. There's more we can do, actually. It doesn't have to be greater than or equal to 0. It only has to imply that it's greater than or equal to 0. So let's say I said x is greater than 0, right? Well, that's okay, because if it's greater than 0, then it's also greater than or equal to 0, right? So it should be happy with that as well, right? But if I said, I don't know, something really dumb like x is greater than or equal to -1, then it's not going to like that very much, right? And there's one other thing that we can do, of course. Whoa, hello. If we can put it back, we have no precondition, and we can just go if x is greater than or equal to 0, then we can call the function, else, I don't know, return 0, right? Okay, we are doing pretty well for time, so I'm just going to do one more example, because what I want to show you is I want to show you a slightly more complicated example. And we're not going to be doing it, we probably won't be getting it, no, we won't be getting to it next week, but the week after we'll be getting to these slightly more complicated examples. But I just want to give you a feel for it. So let's see if we can do it. So I want to go function contains int items int item, right? Goes to bool r. Okay, so let's just go return false. All right, so the purpose of the function, it's going to look through the array, and it's going to check to see if the item is in the array items. And if it is, it returns true, and if it's not, it returns false. All right? So at the moment, this is all good. I mean, this as a function is completely fine in the sense of that function is meeting its specification, but it's not doing what I wanted. So the first thing is, okay, right, what's the specification? Thoughts? Don't tell me the whole thing.
Well, I'll just say one specification. If result is true, implies that there exists one element within items that is equal to the item.
Okay, if the result is true, so that's what I've got here, R implies something. And that is saying, if R is true, then whatever I write here has got to be true. All right? So what am I going to write here? You said it in English. You said there is an element in items.
Yeah, like between 1 and the item's length, that there is some element that is equivalent to item itself. Yeah.
Like that. Notice we use a vertical bar here. In the lab, I used a colon because the lab we weren't using a real tool, right? And I don't like the vertical bar, and I'm probably going to change it to a colon, but not during this course. So this thing here, right, is pretty much saying what you said. It's saying there exists an I between 0 and up to, but not including the size of items, such that the item at that index matches the item we're looking for. Yes. All right? Good. Good. It's a quantifier. You would remember it from Math 161? Yeah? Good, okay. It is kind of useful, that stuff, right? So I'll get to you in a minute, right? So the first thing is, well, let's try verifying it. Well, actually, it's still okay. Right? It's still okay because it's not returning true. If it returned true, we'd have a problem because that case would kick in. But at the moment, that case doesn't kick in because we're returning false. Okay, that's good. So if we try to, let's say, I don't know, for the sake of argument, return true here, then we'd have a problem, right?
So with the pipes by items, that's like the cardinality side.
Yes. Thank you very much. Good call.
Also, the one next to it, that links those two things together.
Yeah, okay, so this is about syntax. So let's go through this. So the first thing here, this is logical implication. You studied logical implication in Math 161 and maybe even in Engineering 101. What is the logical equivalent to implication? A implies B is equivalent to something or something.
Not B implies not A.
B or not A. Whoever said that, well done. So we could actually write this like that. It's actually the same thing, and the compiler just translates it into that internally. But the arrow is sort of syntactically convenient, but it's not really doing anything. Okay, that's point one. So the next point is, what is this here? Yes, you're quite right. So that is returning the cardinality of my array, the length of my array. It's equivalent to writing in Java, items.length. Same deal, okay? I had the opportunity to make up my own syntax, and so I did. It's the same thing, right? And yeah, this vertical bar is basically part of the syntax of a quantifier. Here you define the variable that we're quantifying over, which is always basically takes a form like this. Not necessarily exactly like that, but usually very similar. Then we have the vertical bar, and then we have the condition that must be true for all of the items, all of the indices.
And also, like in Python, we don't have to declare the I as an int, just sort of.
In this particular case, yeah. Most of the time you do, though. If I couldn't do like this, it would not like that. It would say unknown variable. So I have to, if I declare a variable, I've got to go like this. Yeah. Yeah, that's right. And then it's going to be happy and still complain about the problem we had before. Yeah. Yeah. Good. Good. Yeah.
Is that because of the I is something in that range, 0 to Python,
Yeah, it's just how I did it, really. It's an interesting question. Originally, you didn't have to declare types on variables at all. So you could have written this when I originally designed the language. But for some technical reasons, I decided against that. But it turns out I can leave this one here. And potentially, I may add that at some point as a requirement. But I don't know it's necessary. I don't know it's helping. So it's probably fine. I just leave it probably at this stage. Yeah. It keeps the syntax slightly more neater than if I had to put in the type as well. But anyway, okay. Good. Okay. So what we're going to do, what I want to do now, I want to just start by just implementing a bit of this program, right? So let's go like this. While I is less than size of items. Notice I don't need to have braces around here like you do in Java. I can put braces in if I want, but I don't need them, all right? We're going to go I equals I plus 1, and then we're going to go if items brackets I equals item, turn true, and then just because I'm being particularly facetious, I'm just going to, no, I won't do that. That's not going to work. I have to do this, really, don't I? Oh, well, that's fine. So there's my function. Now, it's actually not going to work yet. It's still going to fail, okay? And the reason it's going to fail is because we need to use a thing which is called a loop invariant. And I don't know if have you heard the term loop invariant before? All right, so we're going to get to it. I don't think we're going to get to loop invariants next week, all right? But basically, the way to think about this is that when we go into a loop, any variable that's modified in that loop, we need to say what's true of that variable for all iterations of the loop, okay? So in this case, it's complaining. Let's have a look at the error message. It's saying index out of bounds, negative. So what it's saying is that it thinks that I could be negative. Now, if we look at the function, we actually can see that, no, that's not true. It cannot be negative, okay? But the verifier is not as smart as we are, and it requires a little bit of help. And so what I can do to help it, I've got to write the loop invariant, which is this where clause here, okay? Don't worry too much about it at this stage. Okay, but at that point, now it's working. It's telling me I returned true, and yes, there was an item that matched it. Let's try and break it, right? Let's say it doesn't matter. Let's say if this, right? I don't know the item's 0, and now it's going to tell me post condition not satisfied, right? Sort of working? Okay, cool. So how do we finish it off? What's the rest? All right, go on then.
Put in another post condition of if result is false implies that every element within items there is no item in that.
Yeah, pretty good. So again, this is not going to, well, I need to fix that first, because it's not going to like that to start with. But it's not. It still needs a loop invariant to work, and I'll show you the loop invariant very quickly. Don't worry about this at this stage, because we're going to get to it. J in naught up to I, where items brackets J does not equal item. All right. This is basically it's saying that for every iteration through the loop, up to the point we've got to, it's true that items doesn't equal item. And that's what we'd call a inductive loop invariant. Now, is that enough? I think that is enough. Yeah. I feel like that shouldn't have been enough, but anyway, let's not worry about that at this stage. Oh, maybe it is. Okay, so that's given you the crash course in using the tool, all right? Hopefully you got the idea. That's 5 years of my life invested, and you probably thought, oh, yeah, it looks okay, I guess. Trust me, there was some serious heartache went into making that happen, okay? All right, we're not quite done yet. I want to, we've gone through this.